Paper 1, question 22. P and Q are two triangular prisms that are mathematically similar. Prism P has a triangle ABC as its cross-section. Prism Q has a triangle DEF as its cross-section. AC is 6 centimeters, which is given in the picture. DF is 12 centimeters, which is also given in the picture. And so are the area of this section, which is 10 centimeters squared, and the length of that prism, which is 15 centimeters squared. Sorry, 15 centimeters. Work out the volume of prism Q. Now, knee-jerk reaction there, volume of a prism, area of the face times length, which of course you're given in your formula sheet at the front. I say area of face, area of cross-section, same thing. Now we will end up using that, but right now we can't use it because we don't have the information. We don't have the area of the face, we don't have the length. We don't know the area of that. We don't know the length of that. This 12, you may think it's got something to do with it or not, but by itself it's useless. We can't find anything that we need to find the volume of this prism yet. This is a volume question that is linked with similarity. So before we proceed with that sort of thing, we have to use the fact that these are similar to get the information that we need. Now, in English or in layman's terms, two shapes that are similar or two objects that are similar just means that proportionally they are exactly the same looking. All right? One is an enlargement of the other, or one is a reduction of the other. And as a result, you have a scale factor that links the two. Okay? My advice would be in any similarity question is label the smaller one object 1 or shape 1. So in this case, I'm going to call this one 1. And label the bigger one 2. Now there is a scale factor in play so that when you multiply any length of this object 1, you will end up with the lengths in object 2, and it will be the same scale factor in between, otherwise they wouldn't be similar. In formula terms, this is what I would write. The length of anything in 1, I mean this is a length, this is a length, these are lengths. You could have any two values that correspond to this prism. If you multiply that by a scale factor, you get the corresponding length here. So 6 corresponds to 12, 15 corresponds to this thing here that we don't have. There is a number, or it could be a whole number, or a fraction, or a decimal, that when you multiply one length gets the other. Now you have 12 and 6 here, and hopefully you probably already have clicked that this prism is twice as long, or twice as wide in this case, as the first prism. In terms of using a formula for that, I would have 6 times k equals 12, divide both sides by 6, and I get k is 2. So forevermore, length of 1, or 2 times length of 1, is going to give me the length of 2. Okay, now that makes sense with 6 going to 12, and hopefully you can notice that 15 is then going to become 15 times 2, which is 30. So that means that we have our length now. We're pretty much halfway there, okay? And knee-jerk reaction from there might be that area of face is 10, so we double it and we end up with the area of the face here to get 20. Doesn't work like that. As much as we know that the lengths are connected by a k, areas and volumes are not connected by that same rule, because when you multiply a length by a number, when it comes to area is a measurement of 2 dimensions. So if you have, for example, a triangle here where you have 6 across and 12 across, this triangle would also have a height. And normally you would find the area of a triangle by doing half of base times height. But when you double the base, you're also doubling the height. So when you multiply two numbers that have both been doubled together, you end up with a times 4 effect, or a times 2 squared officially. So when you compare areas, because area is in 2 dimensions, and both of those lengths would be enlarged by k, you end up with k squared. It's what's linked in them. And just to throw out there as well, not that you need it in this question, if you compare volumes of similar objects, because volume is measured in 3 dimensions, when you enlarge a length, you enlarge a volume by k in 1 dimension, k in another dimension, and k in a 3rd dimension, so you end up with k cubed. Okay? Now, we don't need that one today, but it's worth noting. This is the one we need though. Alright? We know that our two is the scale factor for this. We know our k is 2, so k squared just means that the area on that face is going to be 4 times bigger than the area of the other one. So I'll just take this line so you see what I'm talking about here. The scale factor is 2, so sort of the area scale factor is 2 squared is 4. And 10 times 4 is 40. So this here has a surface area, has a face area or cross-sectional area of 40 centimeters squared. We also have from before that the length was 15. Going back to our formula now, here we now have the area of the face. We're good to go with our volume of a prism formula. It's going to be 40, which is the area of the face, times 15, which is, oh, mistake there. Why did that be 15? Yeah, 30. So if we were to double it, that length is 30 centimeters. So we times by 30 here, and that will give you 1200. Remember, it's centimeters cubed because it's a volume. That's the volume of that prism.